So welcome. I am very pleased to introduce Dr. Robert Lustig, who is our speaker today. Robert Lustig is a professor at UCSF in the Department of Pediatric Endocrinology. And like many of us, he had his humble beginnings as an undergraduate at MIT. He then went to get his medical degree at Cornell University and then moved slowly west to St. Louis Children's Hospital for his residency and then UCSF for his fellowship. He then went to New York City for his neuroendocrinology postdoc at the Rockefeller University and then returned to UCSF as a professor of clinical pediatric endocrinology. So he is nationally recognized as an authority figure in neuroendocrinology, having authored a number of scholarly articles and textbooks, but he's also well known in the public eye, having his message delivered in other forms such as YouTube videos. There is one called The Bitter Truth About Sugar that has more than 3 million hits. He's also been featured in the New York Times and in the Huffington Post, and he's also been on television in the Colbert Report. And recently he has a book called Fat Chance that is now on the New York bestsellers list. So we are really fortunate today to have an opportunity to have book signing, which will be done after his talk today. So what is the big fuss about sugar, and how does it affect our waistline, and how does it affect our health? Why is it that we as a wealthy country have one of the most expensive healthcare costs? Our GDP, our healthcare costs took up about 5% of our GDP in 1960, and now in 2008 it's gone up to 17% and projected to go up to 20%. It's the highest in the world. And why is it that 68% of us sitting here today included are overweight or obese, and that number is also expected to rise to 75%. And following obesity is diabetes, and it is expected by the year 2050 that 50% of us will have diabetes. So we have Dr. Lustig to elucidate on these questions, and hopefully will make a big impact. Oh, and one thing I did forget. So other than all the things he's accomplished, during his free time, he's also president of the Institute of Responsible Nutrition, which hopefully he'll give us a little bit of insight into, as well as he received a master's in law. So, and hopefully he'll put that to good use. And so with further ado, here's Dr. Lustig.
Thank you so much, Suji, and thank you all for coming. I will tell you that it is my greatest pleasure and delight to be able to talk to MIT alumni. I am you, you are me, and it was probably the best 3 years of my life when I was there, and nothing could make me happier than to give back, and that's what I hope I'm going to do tonight. So I thank you for coming, and I'll try to make it as light and entertaining as I can. There's a little science and some biology, so I know a lot of you are not biologists, but there's a certain level of logic that comes with this, with the territory of being an MIT alum, and I'm going to call on that tonight. Okay. So tonight's talk is called Healthy, Wealthy, and Wise with a question mark, because the question is, are we? I would pose to you that you already know the answer to that, but we'll talk about it. All right, so first of all, I have no disclosures. No food industry concern is putting me up to this, I promise you. All right, so first of all, healthy. Are we? So here's the past. 2001, 6 million kids are seriously overweight. Well, with all the media attention, with all of the clinical programs, with all the NIH funding, and with Michelle Obama's vegetable gardens, we are now up to 20 million. Here's the present. Currently, there are 30% more obese people walking the earth than there are undernourished people. And these are in the same countries that have undernourished people. Now, how do you explain that? Now, if this is all about behavior, that shouldn't be the case, that you'd have obese and malnourished at the same time. So you have to think, and this looks much more like an exposure than anything else. When you actually look at the demographics, when you look at the pattern of change over time, looks more like an exposure. 366 million diabetics in 2011, 5% of the world's population, and they are chewing through all the healthcare resources. The fact is, we don't have the money for this, and other countries are going broke taking care of chronic metabolic disease. Insurance today costs $2,751 per employee, whether they're obese or not, just to cover the costs of obesity and chronic metabolic disease. So your employer pays your insurer the $2,750, but that comes back to you in terms of rising insurance premiums. You all know you're paying more and getting less, and this is where the money's going. A recent economic analysis of why healthcare costs keep climbing said it's not the fraud and abuse like the Obama administration says it is. It's not the increase in technology. It's not any of these things. You know what it is? It's an increase in chronic disease. 75% of healthcare costs go to chronic disease now, and this is basically breaking the bank. And in fact, Medicare will be broke by the year 2024 if we do nothing. And I just saw a study about 4 weeks ago came out that said that the ACA, when it's finally implemented next year, will cost 32% more than we were originally told by the GAO, which means that if those numbers hold true and the modeling is correct, we actually will, Medicare will go broke by 2019. Now, I am going to be 67 in 2024. And I paid in, and I want my friggin' Medicare. And so should you. Here's the future. Experts predict 165 million Americans will be obese. That will be 42% of the population. That's not overweight, that's obese. 100 million Americans diabetic by 2050. So I will correct Suji. She said 50%, it'll be 30%, 33%. That's still high enough. Okay? That's where all the money will go. And again, Medicare will be broke by 2024. All right, here's the problem. Here's a Venn diagram of the adult U.S. population at 240 million. 30% obese, 70% normal weight. Everybody will agree to that at the moment, no problem. The question is who's sick? Not who's fat, but who's sick. So the standard or exclusive view of this is that it's all the obese person's fault. The obese people are sick. 80% of the obese population is sick. So that would be 80% of 30% of 240 million, or 57 million sick. And they're the ones that are chewing through all the healthcare resources. And if you believe that, then of course it's great to be pejorative against the obese. And after all, that's the only group you can still make fun of, and Jay Leno makes fun of them every night, and everybody says it's their problem, it's their fault, and we don't have to do anything about it. This is the non-starter view of healthcare in America, because it's them, they did it. But there's another view, and here it is. This is the inclusive view, that it has nothing to do with that at all, because yes, 80% of obese people are sick, but 20% are normal weight. Are metabolically normal. They have normal metabolic parameters. They will not cost the healthcare system anything. They will die at a normal age. They're just fat. Conversely, up to 40% of the normal weight population has the exact same metabolic diseases, the same metabolic dysfunction that the obese do. They have type 2 diabetes. They have lipid problems. They have hypertension. They have cardiovascular disease. They have cancer. They have dementia. They have insulin resistance and all of the downstream problems that we know occur with metabolic dysfunction. And they don't even know they're sick. And they end up being 67 million. They end up costing more than the obese do, and they don't even know they got a problem. So they're chewing through healthcare resources and making things even worse and everybody blames these guys over here. So what do you think? Think there's a problem? I think it's a huge problem. Let's take an example. HIV. We all lived through that recently, right? When did HIV become a public health crisis? Anybody know? 1991. Up to that point, it was just the addicts and the gays. 1991. What happened in 1991? Magic Johnson got AIDS. And all of a sudden, everybody said, holy crap, it can happen to me too. And all of a sudden, everything was mobilized because everybody realized this really is a public health crisis. So when people start recognizing that this is everybody, everyone is at risk, not just the obese, that's when we're going to start seeing some traction. The problem is we ain't there yet. But that's my job, is to fix that. Okay. As an example of this, here are two equally fat people. Which one's healthy and which one's sick? And Suji, keep your mouth shut. Go ahead, tell me. Top or bottom? Which one's sick? Bottom. Good. Why do you say that? Visceral fat, exactly. There it is. Intra-abdominal fat right over there. This stuff over here is making that guy sick. Now, this guy over here has got really good love handles. Okay? But he's actually pretty metabolically healthy. And the reason is because his internal organs are way down in fat. It's about the internal organs fat. That's the problem. And there are lots of people who have that and they're normal weight. And that's called TOFI, T-O-F-I, thin on the outside, fat on the inside. Okay? And I'll bet you there are some TOFIs sitting in the audience right now. The key to the kingdom, if you will. It's not about obesity. It never was. Now, the government wants it to be, because then they can say, obesity is a behavior, we're not paying for it. The insurance industry wants it to be, because they say, obesity is a behavior, we're not paying for it. The food industry wants it to be, because they say, obesity has many different causes, many of which have nothing to do with what you eat, like exercise. Therefore, we're not going to change. But it's not about obesity. It's about this chronic metabolic dysfunction, and anyone can get it. And obesity is a result, not a cause. Obesity is a marker for chronic metabolic disease, not a cause. That's what the data show. That's the science. And when you realize that, you realize everyone's at risk. And the question is, what puts you at risk? All right. In order to understand this, we have to understand a little bit of endocrinology, and I'll try to make this very palatable, okay? So over here is the hypothalamus. This is ground zero for energy balance and, intake, expenditure, feeling good, not feeling good, all happening right there. And the inputs to the hypothalamus come from these four hormones. Ghrelin and peptide YY are hormones that come from the stomach and the small intestine that convey satiety or hunger. And we're not going to talk about those for the rest of the evening because there's just not enough time. They're very interesting. I'm very interested in them, but they're not relevant to this discussion. These are the two hormones we're going to talk about, leptin and insulin. Leptin is really cool. It's a hormone that's made by your fat cells, and it goes to your brain and tells your brain how much energy you've got on board. It's like a thermostat, an adipostat, if you will. And it's a servo mechanism, too, because it dictates how much you're going to burn versus how much you're going to store in order to keep yourself relatively metabolically stable and the same weight, constant weight. So when your fat cells start filling up with leptin, leptin goes to your brain and tells your brain, hey, I've got enough energy on board, I can burn some off. And so what happens is that information then goes to these way stations up in the hypothalamus, and those then tell the autonomic nervous system, the fight or flight part of your nervous system, what it should do. Either the locus ceruleus here will get activated, which will tell the sympathetic nervous system to burn off energy at the adipocyte, or the vagus nerve will get activated, which will tell all the viscera it's time to store energy. It will increase appetite, and it will also tell the pancreas to increase insulin secretion. Now, insulin's really cool because insulin tells your fat cell one thing, tells your fat cell store energy. That's your energy storage hormone. Whatever you don't burn, you have to store, and insulin's the way you store it because it opens up, it's the lock and the key to the fat cell to let the energy go into the fat. So it's an energy storage hormone at the level of the fat. But what it tells the brain is something completely different. It tells the brain, hey, I'm in the middle of metabolizing a meal. I don't need any more. Cut it out. And it's part of the satiety signal. So it tells your fat cell one thing, store, and it tells your brain, stop. Kind of cool. Having one hormone do two things. Okay, so that's where the crux of the problem comes in. And I'm going to show you how that works. So here's the paradox that explains what's really going on. Who here has children? What happens if you give a 5-year-old kid a cookie? Yeah, of course they eat it. And then what? They bounce off walls. Okay, called the sugar high. Ask any kindergarten teacher what happens when they pull out the cupcakes for birthdays. Right? They're all bouncing all over the place. That's the end of the lesson. Okay? Why does this happen? Well, the adipocyte gets filled. The leptin tells the brain, hey, I've got this energy on board. I can burn it off. That increases sympathetic nervous system tone, which then either goes to the fat cell, which tells the fat cell to burn it off, so the fat cell gets smaller and the leptin goes down, so there's your servo mechanism. Or it goes to the muscle and tells the muscle, hey, go ahead and twitch. And that's called fidgeting. Okay? And that's what it is. So when I see kids going like this, it's like, good, you're preventing obesity. That's just right. Okay. But here's the paradox. What happens when you give an obese 5-year-old kid a cookie? They're in the pantry looking for more cookies. Did you ever see a sugar high in an obese kid? Doesn't exist. Why not? Because they're not reading their leptin. Their leptin is not doing the job, because if their leptin were doing the job, they wouldn't be obese. And so when they eat the cookie, the leptin might go up, but the brain still doesn't see it because that's why they're obese, so they don't get a sugar high. So that's the paradox. So something is blocking their leptin from dictating what's going on. And so the brain can't see it. And the question is, what is it? What's stopping leptin from working? Why did leptin work for 5 millennia, and now all of a sudden in the last 30 years it stopped working? That's the holy grail of obesity. And that's what we're going to talk about now. So, anybody recognize this patient over here? So HIPAA regulations say I can't tell you his name, but okay, I can tell you what genus and species he is. This is the OB mouse. This is the leptin deficient mouse. This mouse has a defect in the leptin gene, so his leptin levels are smack dab 0. So this animal has no leptin. So this animal's brain thinks he is starving all the time. No matter how fat this animal gets, this animal can't tell. He still thinks he's starving. So this animal eats everything in sight because he thinks he's starving. But not only that, but this animal is the ultimate couch potato. This animal does not move. Now, anybody ever play with rats, like in labs? Okay, they like to nest in the corner of the cage. They build up the sawdust, and you know what I'm talking about, right? Okay, this animal is such a friggin' couch potato that when you drop him in the cage, he stays wherever you put him, like a tribble. Okay, just stays there. Okay. Okay. The only time this animal ever gets off his hiney is if you put the food on the other side of the cage, and he'll waddle over to it, eat the whole thing, and then stay there instead. Okay? Ultimate couch potato. So here's what's happening. So leptin's telling the hypothalamus what's going on. So if you've got it, the hypothalamus says, okay, I sense it, and then one of two things will happen. If the hypothalamus senses it, you get this diamond box over here. It's a nice flow chart. Anorexigenic. That means I've got the energy to burn, and I don't need to eat anymore. And this is good. In which case, then the vagus nerve gets turned off, because that's the energy storage nerve and the appetite nerve. And the sympathetic nervous system tone goes up, just like I showed you before, and that'll burn it off, and that's cool. If the hypothalamus doesn't sense the leptin, then you're going to get this diamond over here instead. Orexigenic. I'm hungry. I'm going to go find some food, and because I think that I don't have enough energy on board, I'm going to try to conserve because maybe I'm starving. And so that's going to cut down on your energy expenditure. It's going to cut down on your movement very specifically. All right? And therefore, the sympathetic nervous system tone goes down, and the vagus nerve goes up instead. Everybody got it? And so what the fat cell tells the brain has everything to do with your behavior. Because if your brain sees the leptin, you act normally. If your brain doesn't see the leptin, you're a glutton and a sloth. That's simple. So here's a leptin deficient patient. Normal weight at birth, gains weight right out of the box. Okay, 6 months, kid's already obese. By age 9, the kid weighs 100 kilos, 220-pound 9-year-old. How'd you like to be taking care of that? Okay, but then they give this kid shots of leptin every day. And look what happens. Loses weight on a dime. And when you look at what kind of weight, it's all fat mass. The lean mass stays fine. Okay, so this patient is losing weight. And he's feeling good. And he starts to exercise spontaneously because now his brain sees the leptin. Just so happens the leptin's coming from a bottle instead of from him because he's got a genetic defect. Great, right? And here's an example. 3.5 years old, pretty horrible, right? And here he is after 4 years of daily leptin injections, indistinguishable from normal. Hormone replacement therapy. We're giving back what's missing. It's what endocrinologists do. Fantastic, right? For 14 people. 14 people are leptin deficient in the whole wide world. And they're all of consanguineous marriages. They all live in either the UK or Turkey. Okay, and they're all of Pakistani or Turkish descent. Great for those 14. What about the rest of us? Well, the rest of us are not leptin deficient. The rest of us are leptin resistant. We got boatloads of leptin. And we got as much leptin as we do percent body fat. Okay, so your fat gets bigger, your leptin goes up. But if your leptin goes up, your brain should see it, and therefore you should burn it off, and you should stay normal weight. But we're not. So this is leptin resistance. We got boatloads of leptin, but we ain't seeing it, and that's the question. So something is blocking that leptin signal, and that's the holy grail of obesity. Right there. Because if we could solve that, we could solve obesity. So we really care. What is the X? What's that question mark? All right, now we're going to talk about insulin. So what does insulin do? Remember I told you, insulin tells the fat cell one thing, it says store, and it tells the brain another, stop. Store, stop, right? Wrong. I lied. And I'll show you why. So this is the patient that got me started in obesity research now 18 years ago when I was a faculty member at St. Jude Children's Research Hospital in Memphis. So this kid here is 15 years old in this picture, and he weighs 364 pounds. And when he was 7 years old, he was perfectly normal weight for height. Normal kid. And then he developed this brain tumor sitting right there. It's called a hypothalamic chiasmatic astrocytoma. Bad thing. Okay? Goomba, sitting right in the middle of his energy balance pathway. And this kid needed surgery, and then he needed radiation to kill the tumor. And he became what we call panhypopituitary. All of his pituitary hormones dropped out, and we had to replace them all. And he started gaining weight at the rate of 30 pounds per year nonstop. Nonstop. And this was a good kid with a good mom who tried really hard, and nothing worked. And this kid just kept gaining weight up to his current weight of 364 pounds. This form of intractable obesity, due to damage to the energy balance system, is called hypothalamic obesity, and it's how I started in obesity research way back when. So the question is, what went wrong? What's going on? Two different hypotheses. Here's one, the standard one at the time, that damage to the hypothalamus damages a satiety circuit, and that causes the patient to be hyperphagic, that they keep eating like crazy nonstop, and that causes the obesity. And we knew that these patients had high insulins, but that the insulin was a result of the obesity. Okay? Because they were obese, that meant their insulin went up. And if that were the case, nothing I can do about it because I can't fix this. There's no place to intervene. Over here, though, is a different hypothesis, that damage to the hypothalamus does lead to obesity, but it leads to it through a different circuitous route, because it tells the vagus nerve to fire excessively because the brain thinks it's starving, right? And that increased vagal firing rate goes to the pancreas and tells the pancreas to make more insulin, and the insulin drives energy into fat, and that's the reason for obesity. So if this were the case, nothing I can do. We're screwed. Kid's screwed. If this were the case, we could block insulin release at the level of the beta cell in the pancreas with this drug, which I know how to use, called octreotide, which inhibits insulin release at the pancreas. Well, 1 year later, here's this kid, 364 pounds, and here he is, 326, first time he took a picture with his shirt off. An apocryphal story about one other patient, not this patient, but another patient. We started the patient, we did this for 8 patients, and then we did it in a double-blind placebo-controlled trial to show that it worked again, and it did. One patient, mother called me up after 1 week, and she says, "Dr. Lustig, something's happening." And I go, "What do you mean?" You know, the kid hadn't lost any weight yet, it was just 1 week. "Well, we would go to Taco Bell, and my daughter would eat 5 tacos and an enchilada, and she'd still be hungry. And we just went to Taco Bell, and she ate 2 tacos, and she was full. And she just started vacuuming the house." You know, these were kids who sat on the couch, ate Doritos, and slept. And this kid's vacuuming the house. So one kid became the manager of his high school basketball team, running around collecting all the basketballs. 2 kids started lifting weights at home. 1 kid became a competitive swimmer. They all started exercising spontaneously. These were kids who did nothing. They sat, they slept, and now they're exercising. Because I got their insulin down? Yeah, because I got their insulin down. Now this is the pièce de résistance. This is the absolute slam dunk. So this is a 13-year-old, very pretty Hawaiian girl who happened to then get in a car accident. And she stroked her hypothalamus. And she was in the ICU for about a month. And then when she came out of the ICU, she started eating and gaining weight like crazy. And this is her 1 year later. Well, it just so happened I was giving grand rounds at Kaiser Honolulu. And so they invited the daughter and the mother to come hear the talk because they were thinking that maybe she had hypothalamic obesity too, and maybe they should put her on octreotide. So I was there and I helped consult. And here she is 1.5 years later at her high school graduation. How about that? Now, anybody want to tell me that's gluttony and sloth? The biochemistry drove the behavior. And when we fixed the biochemistry, the behavior changed. In fact, biochemistry always drives behavior. All behavior is biochemistry. Sometimes we're smart enough to figure out what it is. Sometimes we're not. Okay? For 100 years, schizophrenia was a behavioral problem. Now we know it's a defect in dopamine neurotransmission. And I've actually heard more recently, the American Psychiatric Association, which was just 2 days ago, that it might actually be a defect in glucose transport in the brain, GLUT1 and GLUT3. How about that? Well, so we said, all right, maybe this is true in obese adults who don't have brain tumors. So we did a study in adults, and this is just an example. Here's a woman, Christmas 1998, I think she's holding up food, and here she is 35 pounds later in her jogging togs because she wanted to show me that she liked to exercise. She actually enjoyed exercising. Oh my God, how about that? All right? We changed her behavior by changing her biochemistry. So how does this work? So let's take Suji over here. Okay, she's nice and thin, right? Okay, I'm very jealous. She's very nice and thin. She eats 2,000 calories a day. She burns 2,000 calories a day. She feels good normal day. Is she going to gain weight, lose weight, or stay the same? Stay the same, right? Because she burns what she eats, nothing to store. Fine. Now let's do a little thought experiment. I'm going to put an IV in Suji's arm, and I'm going to follow behind her all day. And every time Suji reaches for food, I'm going to pump her full of extra insulin that she didn't want or need. I'm going to over-insulinize her, just like we do with our type 1 diabetics who gain weight, right? So this is the new Suji. She's going to wake up in the morning. She's going to start out the day eating 2,000 calories, just like before. But now, because of the excess insulin I'm pumping her full of, what's going to happen? 500 of those 2,000 straight to fat, right off the top. Look what the IRS does to your paycheck. Gone before you had a chance to spend it. Gone before Suji had a chance to burn it. She is now 500 calories heavier. If she stood on a scale, she'd weigh 1/7 of a pound more because of what I did to her. So far, so good? Now, she ate 2,000, but she lost 500 to her fat. How many calories are left to burn? Come on, this is MIT. You got to get this right. 1,500, right? But her body wants to burn 2,000 because that's where it feels good. And how many calories you burn and how good you feel are synonymous. Things that make your calorie expenditure go up make you feel good, like ephedrine off the market, caffeine for 2 hours, exercise. Things that make your energy expenditure go down make you feel lousy, like hypothyroidism, starvation. So, Suji now only has 1,500 calories to burn, but she wants to burn 2,000. So what do we call this state where your body has fewer calories than it wants to burn? It's called starvation, right? So how do you feel when you're starved? I do it once a year. Crappy, tired, slothy, sit on the couch, don't want to do anything, don't want to exercise. Maybe play video games. And of course, hungry. So in a world of free access to food, which we all live in, what's Suji going to do? Eat back the 500, right? So now instead of eating 2,000, now she's eating 2,500, right? Except I'm still pumping her full of insulin. 100 calories right off the top of those 500. Now she's 600 calories heavier. She's only up to 1,900 to burn. It's called an asymptote, right? I can say that here, right? She never quite gets there. So she goes to a doctor, she goes to a nutritionist. She says, Doc, I don't get it. What's happened to me? Why am I gaining weight and I don't feel so good? And the doctor looks at her behaviors and says, I know why you're fat. You're a glutton and a sloth. And it's true. Suji is now. But not because she chose to, not because she wants to. It's because she has to. It's a biochemical drive set up by the insulin I pumped her full of. So the answer to the question of the cause of leptin resistance is insulin. Insulin blocks leptin signal. Now, the question is, why? Why does this happen? What's the selective advantage? Why would God do this to us? And the answer is, because there are 2 times in your life you actually have to gain weight. Anybody know what they are? Sorry? Pregnancy is one. Yep. And what's the other one? Getting closer. Puberty. Puberty and pregnancy. You have to gain weight in order to become reproductively competent and to carry the baby to term. So if you didn't gain the weight, species would die out. But if leptin worked right all the time, you could never gain the weight because you'd be burning it off with the sugar high. So doesn't it make sense that the same hormone that causes the weight gain at the level of the fat cell should also be the same hormone that blocks leptin at the level of the brain, so that you can gain the weight? And then you cut the cord and the hormones change and the insulin goes down and you can lose the weight and you can start all over again. It actually makes perfect physiologic sense that insulin should block leptin. That's good. Twice in your life. Problem is, it ain't twice in our life anymore. Now, we're hyperinsulinemic 24/7, 365. So the question is, how come? Why is it that today, if you did a glucose tolerance test on a patient today, they would release double the amount of insulin that they would have 30 years ago? Where did the excess insulin come from? What caused it? I'm not going to tell you. I'm going to let Will Smith tell you, okay? But the problem is I have to put the, what do you call it here, because we didn't have an audio, so we're going to have to, let's see what happens, all right? Can you hear okay?
What? Guess I owe you some answers, Hoss.
Oh, what, you feeling chatty all of a sudden? Sorry, I can't talk right now. I got some secret cases of my own I'm working on.
I hate to tear you away from your video game.
All right, I'm hanging up.
You know the most destructive force in the universe?
Sugar?
You know, look, if Hollywood knows this, why don't you? I was on a flight to Buenos Aires. I almost fell out of my friggin' chair. When I saw that, I said, oh my God. All right, so anyway. Yeah, sugar. Why? Why sugar? Let me hold this back. Doesn't want to come back up. There we go. All right, good. Sugar. So these are two papers, actually journal articles. This was from the New York Times Magazine. Maybe some of you saw it back in April of 2011. Gary Taubes wrote about our research at UCSF. And this is a comment that we put in Nature magazine last year called The Toxic Truth About Sugar. My colleagues Laura Schmidt and Claire Brindis, who are alcohol researchers and public health people, where we basically describe that sugar meets all the criteria that alcohol does for regulation. Got quite a send-off, especially by the libertarians. Okay, so what is this stuff? What are we talking about? So, who here is a chemist? Who here had 541? Oh, good, all right. Here's glucose over here, 6-membered ring. Here's fructose over here. That's the sweet part of sugar, the one we care about, the one we seek. Glucose isn't very interesting. You don't see people running around chugging Karo syrup, do you? Okay, glucose, you know, you can take it or leave it. It's good in a pecan pie, that's about it. Okay, fructose, that's the stuff we go out of our way for. That's the frappuccino, okay, right over there. Okay, 5-membered ring. Okay, and it's a big deal that it's a 5-membered ring. You'll see why in a minute. But here's sucrose over here. 1 glucose, 1 fructose, O-glycosidic linkage linking the two. The enzyme sucrase in your intestine cleaves this in about a nanosecond, and you absorb the two. So basically, high fructose corn syrup, sucrose, equivalent. Because they're both moieties at the same time. You absorb both, equivalent. All the studies that pit high fructose corn syrup against sucrose show no metabolic difference. I agree. They're equal. They're equally bad. They're equally toxic. And I'll show you how. And here's the thing you need to know. Of the 600,000 food items in the American grocery store today, 80% of them have been spiked with added sugar. And that's not for your purposes. That's for the food industry's purposes. Because they know when they do, you buy more. So our food has been fructosylated. Okay? You can't even find food that doesn't have extra sugar added to it. And there are 56 names for sugar, so you can't know them all, except for Stephen Colbert. He says he knows them all. So the question is, all right, so why is sugar so bad? First of all, does sugar cause obesity? Big question. Turns out, yes, it does, but not the only thing that causes obesity. There are many things that cause obesity. Here's a meta-analysis of sugar and obesity, showing that if you lower sugar, you can see the little bit of an effect here, and if you raise sugar, you can see the little bit of effect here. Bottom line, it's worth about 0.8 BMI points. So, can sugar cause weight gain? Yes. Is sugar a cause of obesity? Yes. Is it the cause of obesity? No. Many things cause obesity. Actually, of all the different foodstuffs, the 2 foodstuffs that are the most obesogenic, French fries and potato chips. French fries and potato chips. Okay? But we knew that. All right. But sugar comes in a distant third. So yes, it does cause obesity, but it's not the big kahuna in terms of weight. The question. But we're talking about chronic metabolic disease today, not obesity. That's the point. All right, so here we go. Here are the 10 most obese states in the nation. No surprise. Anybody from them? No? Nobody? Oh, man. All right. Here are the 10 laziest states in the nation. What's going on over there in Nevada? Guess you can only burn so much energy going like this, right? Now it's like this, right? Okay. Here are the 10 most unhappy states in the nation. No surprise either. Here's the adult diabetes rate. Here's the adult heart disease rate. And finally, here's soda per capita consumption. What do you see? Yes, I see Atlanta too, in my crosshairs. Okay? Actually, I mean, people say to me all the time, look, Dr. Lustig, you know, this is pandering to the audience. Because you know as well as we do, this is correlation, not causation. Poor people drink soda. Fat people drink soda. That doesn't mean that soda makes people poor and fat. Indeed. This is correlation, not causation. We have no directionality here. Snapshot in time. You don't know which way things go. And I'm very clear on the difference between correlation and causation. What about the rest of the world? Tripling of sugar consumption over the past 50 years, as you can see here. Per capita consumption. Look at Brazil. Brazil used to not be able to afford its own sugar. It was very poor. They made it and they sold it, but they didn't eat it. Now they're a BRIC country. Now they can afford their own sugar. And now Brazil has the highest rate of increase of type 2 diabetes in the world. Not the highest prevalence. That's reserved for Saudi Arabia, Qatar, UAE, Kuwait, and Malaysia. Now, how do they do this?
They got rich.
Nope. Nope. Worse than that. Go ahead, Bill.
They don't drink alcohol.
Ding, ding, give the man a cigar. No, don't give him a cigar. No alcohol. But they got soft drinks like they're going out of style. Why? Well, it's hot, and the water supply is a question mark, and no alcohol. This is their reward. Okay? This is their reward. And I will show you that sugar, placates reward. In fact, sugar is addictive. So this is their addiction, and it's legal. And they are, if you ever, I was in Kuala Lumpur, and I'm telling you, people's bellies entered the room 10 minutes before they did. Things were not good, not good. Okay. So correlation is not causation. That is true. But we have causation too. Okay, this is work we just did. It was published in PLOS ONE 3 months ago, and I'm very proud of it. It's the best thing I've ever done. And I did it with Dr. Sanjay Basu, who is now at the Stanford Prevention Institute here at Stanford. And what we showed is that, this is not IMPRESS, this is 3 months old, showed that the change in diabetes prevalence worldwide correlated with the change in sugar availability country by country over the past decade, with lots and lots of bells and whistles in terms of statistical analysis. This is what they call an econometric analysis. So we had the movie, not the snapshot. We could follow the change in diabetes prevalence as the change in sugar availability country by country occurred. And we could actually determine dose, duration, directionality, and finally precedence, and that was the important one. And we showed that the change in sugar availability preceded the change in diabetes by 3 years in both directions, up or down. Okay? And that's what you need in order to be able to say causation. So what we have is really a pretty darn tight case that only changes in sugar availability correlate with changes in diabetes prevalence over the decade worldwide. Every extra 150 calories total consumed around the world increased diabetes prevalence by only 0.1%. Nothing. But if those 150 calories happened to be a can of soda, then diabetes prevalence increased 11-fold, or 1.1%. And here in America, we don't consume 1 can of soda a day, we consume 2.5, based on our sugar consumption. So this is 2.4%. And considering that diabetes prevalence in America right now is 8.3%, you can see that 25% of all diabetes in America and really worldwide is due to sugar and sugar alone, nothing else. The question is why? Well, because fructose is not glucose. That's why. Remember, 6-membered ring, 5-membered ring? It matters. And I'll show you why. Second problem. Fructose is 7 times more likely than glucose to bind to proteins. And when they do, they release little hydrogen peroxides called reactive oxygen species. And that is the cellular aging process. So sugar contributes to cell aging and cell death. And I will show you that as well. So here's an example of how fructose is different from glucose. These are patients that were admitted to the Clinical Research Center at San Francisco General and fed either complex carbs for 2 weeks or sugar for 2 weeks in a crossover fashion, randomized crossover. And then an MRS, magnetic resonance spectroscopy, to measure the amount of water versus liver fat. And you can see here, here's the fructose diet, and here's the lipid fraction. And here's the complex carb diet, and here's the lipid fraction. This is isocaloric, same number of calories for the whole 4 weeks. But Fructose versus complex carbs, 38% increase in liver fat on the high fructose diet during those 2 weeks, and a halving in insulin sensitivity. These are bad things to happen. Okay, that's chronic metabolic disease at the same number of calories. How about the cell aging process? Let's talk about that. So this is called the Browning or the Maillard reaction. Anybody know what hemoglobin A1C is? Okay, you know what that is? It's what measured in diabetics to see whether they're in good control or not. The higher the blood sugar, the higher the hemoglobin A1C, and that's bad for you because it damages cell membranes, it damages proteins, and it releases those reactive oxygen species. Well, here's the problem. You can either roast your meat at 375 in the oven for an hour, or you can roast your meat at 98.6 degrees for 75 years. But the answer is the same. You brown. Okay, and if you don't believe me, here's newborn rib cartilage, nice and white, and here's 88-year-old rib cartilage right here. Okay, so you're browning even as you sit there. And if you had orange juice this morning, you're browning faster. This is not good. Okay, you want to stop browning? Get rid of the juice. Here's just another example for the biochemists in the room. So let's take a little test tube, okay, and stick some albumin, some protein in the bottom of the test tube, and add some glucose or some fructose, and then cap it and just leave it in the sunlight. And every day you come back and you stick the test tube back in your spectrophotometer and you measure the fluorescence, which would be the binding of the two together. So here's the rate of reaction for glucose, and here's the rate of reaction for fructose, 7 times faster. Here's the rate right here, 7 times faster. And look at the number of reactive oxygen species formed, 100 times greater for the same amount of protein and the same amount of carbohydrate, because fructose drives the aging process. So you say, oh, wait a second, that's in a test tube, who cares? Let's talk about animals. Okay, so this is a rat, and this is a rat treated with either sugar or starch with normal diet, that's methionine choline sufficient, MCS, or take away the methionine and choline, and that causes fatty liver, but only when you give it sugar, not when you give it starch. And you can see this is in humans. Fructose consumption daily versus non, and this is how bad the steatosis or fatty liver is, and the fibrosis, the cirrhosis that occurs. You can see that the amount of sugar consumed correlates in humans with the amount of liver disease. Okay, that's the healthy part. Now let's talk wise. Who's wise? I don't either. Not anybody in America, that's for sure. So is sugar addictive? Let's start with that. We're talking about brain stuff now. Is sugar addictive? You know, the lay public seems to know this. How come the scientists are so reticent? Just 2 days ago, I was at the American Psychiatric Association, and we had a whole symposium on food addiction. And there were some psychiatrists there who, you know, just did not believe. But there were plenty who did. And it was kind of cool, actually, to see that, because they see this in their own patients. Well, here's what I can say. This is the area of the brain called the reward center, the nucleus accumbens. And this red stuff here is dopamine D2 receptors. Dopamine is the feel-good neurotransmitter, the pleasure neurotransmitter. Okay? When you go out and get yourself a Cinnabon, you're trying to up your dopamine. That's what you're doing. Okay? That's just the behavior that leads to the upping of dopamine to get the pleasure response. Right? The problem is that dopamine downregulates its own receptor. Most things do downregulate their own receptor. That's called tolerance. And that's on purpose, okay? Because you don't want to overdo it, because you might actually cause cell death when you do that. So here's a control brain with lots of dopamine D2 receptors, and that's good. And here's a cocaine brain, okay? That's an addict brain. And that's the neuroanatomic correlate of tolerance, that's what you're seeing there. There's no dopamine receptors. They're downregulated way down. And so what you need is you need more cocaine to release more dopamine to occupy fewer numbers of receptors. That's the law of mass action. Well, here's a control brain over here, and here's an obese brain. What do you see? Same thing. Not quite as bad, but the same concept. Downregulation of dopamine receptors. So obese people have to eat more to get the same level of reward as thin people, because their dopamine receptors are downregulated. And there are genetic defects in the dopamine receptor, and those people are massively obese because they have to generate lots of dopamine to get only a little response. So, is sugar addictive? Is that what's going on? Is it driving this phenomenon? So this is in animals. This is what you have to satisfy in animals. Binging, withdrawal, craving, and cross-sensitization with other drugs of abuse. Meaning, you take an animal and you addict it to one substance of abuse, like cocaine, for 3 weeks. And then you expose it to another substance of abuse, like, say, amphetamine. And they're addicted to the second drug, even though they've never seen the second drug before. That's cross-sensitization. The reason is because when you downregulate the dopamine receptors from the cocaine, there are no dopamine receptors for the amphetamine either. Everybody got that? Because they're the same dopamine receptors. So that's what we call addiction transfer. Oprah was an expert on this. Okay, she talked about it all the time. Okay, so sugar satisfies all 4 criteria in animals. All 4. Okay, what about in humans? We don't know yet. Correlative data, not causative yet. Now let's talk about changes in behavior. Here we are in San Francisco. Everybody know what the Twinkie defense is? Who doesn't know what the Twinkie defense is? 2 people. All right, real quick. Dan White killed George Moscone and Harvey Milk at the San Francisco City Hall back in 1979. Okay, Dan White was a little. Anyway, his lawyers used the Twinkie defense as his defense, that he was so hyped up on junk food that he didn't know what he was doing. Jury didn't buy it. He went away for 25 years. 2 days after he was let out, he killed himself. Okay, so he was a little. Anyway, but the Twinkie defense. Well, this was a paper that came out in 2012 called The Twinkie Defense, Relationship Between Carbonated Non-Diet Soft Drinks and Violence Perpetration Amongst Boston High School Students. Now, this is correlation, not causation. We don't know if violent high schoolers drink soda, or does soda cause high schoolers to be violent? We don't know that yet. Okay? I can tell you that a colleague of mine in the UK did this exact study in prisoners, and found that the prisoners became much more docile when they took the soda out of the prison. Very interesting. And finally, what about dementia? Since that's, the reigning concern of the middle age and the older age. Here's what we know. We know that obesity is associated with dementia. There are numerous studies showing that. We know that obesity alters the neural projections in the prefrontal cortex that are consistent with dementia. We know that. We know that sugar generates insulin resistance and hyperinsulinemia in animals. I already shown you that. And we know that insulin resistance and high insulin levels are correlated with people with dementia in humans. We know that the Western diet correlates with dementia. That's well known. We just don't know what aspect of the Western diet. It's just the Western diet. And here's the interesting one. Both fat and sugar will cause obesity in rats, but only sugar caused cognitive decline, not fat. In fact, actually, fat made cognitive function better. Now, this is if they were omega-3s. So we have causative data in animals. We have correlative data in humans. We do not have causative data in humans. But when we do have causative data, do you think for a minute we're going to have a sugar problem? Now, it's been said many times, sugar makes you stupid. Okay? But if it gives you Alzheimer's, that's going to be a big deal. We're not there yet. We are not there yet. We only have correlative, not causative. But are you concerned? A little? Maybe? Just a touch? Good. All right. At the American Heart Association, they recognize that this is a problem. Now remember, this is the group that said fat was bad, right? Back in the early 1980s. They have now taken it back. They now say the fat hypothesis is dead. Sugar, on the other hand, we said, and I contributed to this, so I'm very proud of that we need to reduce consumption from an average of 22 teaspoons of added sugar per day in America down to 9 for males and 6 for females. That's a reduction by 2/3 to 3/4. That's a huge reduction. The question is, how are we going to do that? when half of the sugar that we consume each day is in foods we didn't know had it. 1/3 in soft drinks and fruit juice, beverages, 1/6 in ice cream, other desserts, candy, 1/2 in things that we didn't know had sugar, like tomato sauce, barbecue sauce, ketchup, salad dressing, hamburger buns, hamburger meat. So when people say they don't eat sugar, they lie because they don't know. Okay? They're all eating it. We have a baseline like you can't believe because all of our processed food has been laced with it, it's spiked with it, because they know, food industry knows, when they add it, you buy more. And that leads us to who's wealthy? You? Doubt it. Here's what's happened to our food dollars. 1982, 2012, 30 years apart. Meats, way down, right? Why? Low fat. So meats went way down. Fruits and vegetables, exactly the same. No change. With all the music, and all the eat your fruits and vegetables, no change. Grains and baked goods, up 1%. So yes, carbohydrates up, but not all that much. Dairy products, way down, because everyone is lactose intolerant now. Processed foods and sweets, 11.6%, 22.9%. Doubled in 30 years, indeed. And finally, beverages, basically the same. That's it. Processed foods and sweets. So, this is who's wealthy. Despite the economic downturn of 2008, which you can see right here, okay? Here's the S&P 500, and here's McDonald's, Coke, and Pepsi's stock price over the past 5 years. They are doing very well, thank you. And here is Hormel, ADM, General Mills, ConAgra, Procter & Gamble, Kraft, Hormel against the S&P 500. Bottom line, you want to make money, invest in a food company. They have the market. They know how to increase market share, don't they? So for further reading, whole bunches of academic articles, and more academic articles, and more academic articles, and a non-academic. So this book has everything I've just talked to you about, plus some, and that's very specific. I wrote this book for doctors, because doctors need to learn how to do this. But my publisher said, if you write it for doctors, we're not publishing it. So you need to write it for the general public. And I said, okay. And I'd never written for the general public. So, I had an editor, and she made it light and funny, and, I've been told, everything that's funny in the book is hers, I swear. Her name is Amy Dietz, and I'm very indebted to her, and she's a wonderful woman, and I love her dearly. Okay, but the bottom line is, you're getting screwed. In fact, you're getting frucked. And you need to know it for your own health, for the health of your family, and really for the health of society. Because I assume you want your Medicare. And if we don't turn this around, and we got 11 years to do it, maybe less, we're all screwed. And we need to do something, and we need to do it now. And that is why I went to law school. I went to law school very specifically to learn, number one, how a personal health crisis becomes a public health crisis. What has to happen for society to get involved and for it to be legal. And the second thing is to learn the tobacco playbook, because I think you can see some very clear parallels and similarities to what tobacco did and how tobacco used people and how the subterfuge in terms of tobacco advertising went on during the course of those 4 decades before we finally got them on very specific legal grounds. So we have started a 501c3 nonprofit organization to provide medical, nutritional, and legal analysis and consultation against big food, called the Institute for Responsible Nutrition. And there's our website, responsiblefoods.org. We have 4 planks in our platform. Education, obvious. We're going to be working with the SFUSD to try to improve nutrition education amongst middle and high schoolers so that they actually know what they're doing and don't necessarily take what the food industry gives them. Research, very specifically looking at communities and ways of impacting communities, and also assessing metabolic risk in people and in communities, looking at biomarkers for disease and sugar consumption. Advocacy at the level of Congress, at the level of the FDA, because the FDA is a captured agency. The USDA is a captured agency. There's so much movement from private industry into these into these agencies that basically, the agencies are owned, and they're not owned by you. And finally, action. And when I say action, it's a euphemism for litigation. And we're looking at this very specifically, and the question is, are there legal doctrines and legal theories similar to what was used in tobacco that could be brought to bear on the food industry, especially now that we have proximate cause for diabetes, and since that's a big kahuna in terms of dollars. So please let me know if you'd like more information. And with that, I thank you, and I'm happy to answer questions. And the book is in the back, and I'm happy to sign, and I'm glad you're here. But
How do the sugars and alcohol compare to, where's alcohol?
you mean, I'm not sure what you mean. Alcohol is not sugar, but I mean, what do you mean?
Have carbohydrates, I guess, so it's like
Well, alcohol is metabolized through the fat pathway, and fructose is metabolized through the fat pathway. And I've actually written several articles. In fact, I wrote one. I've got one here. I'll show you back here. Where is it? Is it this one? No. There it is, right there. Fructose. It's alcohol without the buzz, because they are metabolized by the liver exactly the same and cause the same metabolic diseases. Chronic alcohol exposure and chronic fructose exposure are virtually identical. There's something called alcoholic fatty liver disease. There's something called non-alcoholic fatty liver disease. They are the same. Under the microscope, they're exactly the same. The only difference is that in alcoholic fatty liver disease, the alcohol did it. In non-alcoholic fatty liver disease, the sugar did it. And it makes sense that that would be the case, because after all, where do you get alcohol from? Fermentation of fructose is called wine, right? We do it in Napa, right? So that's the deal. So how do they compare? They compare almost congruently. The only difference is because the brain doesn't metabolize fructose, you don't get the CNS effects. So you don't drive your Lamborghini into a tree after drinking a soda. If you did, we'd have outlawed it years ago. That's the difference. You had a question?
Yeah, my question is about the microbiome.
The microbiota inside your
Yeah.
intestine. Right.
So, I mean, I'd just like you to comment on that and
Mhm.
stuff that's coming out,
You bet.
new results, and
Sure.
what you think about that.
Sure. So did everybody see the New York Times Magazine on Sunday? Michael Pollan had a big article called Germs, right? Okay. So this is the intestinal microbiota, and this has been a big hot topic now for about 10 years as to whether or not the germs in your intestine could make you obese or could make you sick. And I absolutely think that is absolutely true, that the germs have a lot to do with what happens. There's a hypothesis out there called leaky gut. Heard of it? Okay. Leaky gut. Bruce Ames over at Children's Oakland first introduced this to me. And the question is, you have this intestine, and the intestine is basically this tube that runs through your body that's not supposed to let things that don't belong to across. It's supposed to be what we call tight junctions. They're supposed to protect from things getting in. But sometimes those tight junctions can be breached. And when they are breached, things that shouldn't get in do. And that may be one of the reasons for food allergies, that they've gone up so high, is because they're being breached. And we know that we can measure endotoxins. These are toxins that are on bacteria in the bloodstream of obese people. That suggests that their gut is not holding the line, and that something is allowing the gut to be breached. And the question is, what is it? And studies have shown that sugar does it, because it depletes ATP within the intestinal cells, and the ATP is necessary to keep those tight junctions functioning. So it's possible that leaky gut is contributing to obesity. Now the question is, what bugs are doing it, and how do you get the right bugs versus the wrong bugs in your intestine? And the short answer to that is fiber. That's what the data show, that if you use a high fiber diet, you can change your intestinal bugs to the ones that are not dangerous instead of the ones that are. So I think fiber is extraordinarily important in terms of protecting against this phenomenon. And there are a lot of studies that now show that when you eat real food, your intestinal microbiota change back to the way they should have been, whereas on processed food, they're all the bad stuff. Lastly, fiber protects against absorption of nutrients really fast, so more get delivered down the intestine. And that's good because that means your liver isn't getting everything all at once. Because when your liver gets everything all at once, that's when you get sick, because your mitochondria in your liver can't handle it. So there are a whole bunch of reasons why fiber is good, and there are a whole bunch of reasons why germs matter. So I'm for it. Yeah.
So on a practical level, what are the strategies you would advise for people trying to remove sugar from their diet? I mean, if it's truly like a drug,
Right.
it's not so much a question of, hey, tomorrow I'm stopping right now.
Right.
But it almost has to be some kind of process. And for the layperson, a lot of these terms get lost and they
sure.
say, forget it.
Absolutely.
And so I guess how do you convey this message to a layperson?
Three words. Eat real food. That's it. Eat real food. If you eat real food, all this gets taken care of. Because what is real food? It's low sugar, high fiber. What is processed food? It's high sugar, low fiber. If sugar's the bad guy and fiber's the antidote, then eating real food basically takes care of the problem. And that's what all the studies show. So you have all these diets out there. This is chapter 17 in the book. All these diets. You got the Atkins diet, you got the glycemic index diet, you got the paleo diet, you got the South Beach diet. You know, you got every friggin' diet, you know. And the fact is, they all work, except they don't. Because if any of them worked, there'd only be one, right? Every diet works for 2 months, and then they don't work. Why does every diet stop working? Because every diet regresses to the mean after 8 weeks. That's what Chris Gardner at Stanford showed in his A to Z study, is that everybody who said they're on a diet, when you actually look at what they're eating 8 weeks later, they're not on it anymore. And so every diet stops working. Real food is not a diet. Real food is real food. And real food does better than any diet. The problem is real food's hard to find now, because 600,000 food items, 80% are not real food anymore. That's the problem. So that's what, when I tell people, the simple message, that's the message. Michael Pollan said, eat food, not too much, mostly plants, seven words. I got 3. Okay, I beat him. All right, go ahead. Yes.
So for
And
all
then
the
somebody had a question over here. I'll get it.
So you're doing a great job, and millions of people are reading your books and articles
about
and
millions.
watching the videos.
Whatever.
For those of us who don't have the ability to influence as many as you do at once, I'll be in Safeway, standing in line with some food, and I'll see someone in front of me with like half a dozen 2-liter bottles of soda, a bunch of bags of chips, and a bunch of white bread.
Yep.
I haven't yet, but I'd like to start talking to people like that. Do you ever try
You're
that?
on your
And
own.
What can you do? I mean, more people need to know this sooner. Than
Listen,
50 years
I
from now.
agree. More people need to know this, but it's not for you to tell them.
Why not?
Seriously, I'm serious. You know why? You know why? They're going to pull a gun on you and they're going to shoot you. That's why. Because if they're eating that, they're probably, the Twinkie defense.
All right. Different question. How do you tell if you're TOFI without getting a CT scan or MRI or whatever, or if my kids are TOFI?
Right.
How do I know?
Well, it's hard to know. It's actually hard to know. Waist circumference is the cheapest, easiest measure. In kids, it's hard because we don't have good standards. In adults, it's a little easier. Waist circumference will tell you a little bit more. But ultimately, the only way is lab tests right now. MRIs will tell you, of course, but they're expensive as all get out, and you're not going to be able to convince your physician to send you for one. The lab tests that I use are fasting insulin, lipid profile, ALT, uric acid, and hemoglobin A1C. Can you say those again? Sure. Fasting insulin, lipid profile, ALT, hemoglobin A1C, and uric acid. Those are the ones that tell me the most.
Is that in your book?
Yes, it is.
Okay.
All of those are in the book, in chapter 19. Yes.
Can I ask a follow-up question on that?
Sure.
So it is difficult, and you mentioned something about, getting pregnant and going through puberty. Well, menopause is kind of a combination of those things.
Right.
And I have been going back and forth with my doctor, trying to get lab work done, trying to get this, that, and the other done
Right.
to figure out, because I do eat a plant-based diet. I don't drink soda.
Good.
And in the last couple of years, I've put on a lot of weight. And I struggle
Yep.
with these things about like feeling like my energy is decreasing.
Right.
And so then I'm craving more sugar. And so I get that it's sort of this death spiral, but I'm trying to figure out ways to like get my doctors, and they're like, oh, you need to go see a GI person, or you need to go see a hormone specialist,
Right.
but all my tests come back like I'm super healthy.
What tests?
So I
Any of
don't
the
have
ones I
high
just
blood
mentioned?
pressure. I don't have cholesterol issues. My blood sugars are totally normal.
Blood sugar is the last thing to change. I measure blood sugar, but to be honest with you, it's the least helpful. Because once your blood sugar's altered, horse is out of the barn. You're already super sick.
Okay,
So
so
I would get a fasting insulin. This would be a good thing. Have you had one? Now I'm going to tell you, your physician probably doesn't know how to interpret it and doesn't know what it's for, and would probably tell you, that's no good for anything.
Well,
We
what
use it
would
all
be
the
a
time.
fasting insulin thing? Like I go in to get the blood work, you don't eat for 12 hours,
Yeah, right.
whatever,
That's right.
beforehand. So
That's right.
then yes, I have been tested.
Okay, so if you have a normal fasting insulin and you're still gaining weight, then the question is, all right, is there something going on with your mitochondria that they're not burning?
So
that
how
can
do I
happen,
find
and that can
that
happen
out?
at menopause. That can happen at menopause. We're not sure why, but that's part of the aging process also. Who noticed that their lives changed when they hit 44? Okay, something happens, and we don't know what it is, but mitochondrial function seems to have limited life, and things tend to go south after 44, and it's really hard to stay normal weight after 44. In part because mitochondrial function changes. And so you don't burn energy at the same rate. So you don't feel as good, and you tend to put on weight because you're not burning at the same rate as you used to. And we're not sure why. It may be a DHEA problem. This is one of the sort of funky things that people are talk about in terms of health and wellness. I don't know the answer specifically, but we know it occurs.
Nutritionists say, well, eat healthier. Well, it's like, okay, well, I don't eat any, dairy. I don't eat any meat.
Well, meat's not bad. Meat's got a bad rap.
Work well for me. I haven't
All right.
eaten meat since I was in my teenage
All right.
years.
Well, I mean, look.
I feel like I'm one of those like obese people that's like totally healthy. Like
Do you eat
that
fish?
whole-
Do you eat fish?
No,
Eat fish.
I can't.
Why not?
It grosses me out.
It grosses you out. Do you take fish oil?
No.
Take fish oil.
Like the flaxseed and the other, like,
You're getting enough omega-3s? You know you are?
I don't know for sure that I am. I try.
Well, you maybe seriously, actually, that might help a lot.
Okay.
If you're omega-3 deficient, that might be part of the problem. Yep.
I'd like to just suggest a hypothesis. Is this on? Yeah, for the recording. It's okay? Okay. About why postmenopausal women typically gain weight.
Okay.
What menopause does basically is reduces your progesterone production to zero.
Right.
The body continues to produce some estrogen in fat cells,
Yep.
so your
A
estrogen
little
stays
bit.
about half of what it was anyway.
Right.
But the progesterone is works with thyroid, and thyroid works with progesterone. So when you become progesterone deficient, basically in menopause,
Yeah.
your thyroid is no longer working as well as it should. And unfortunately, the thyroid test, which doctors use to diagnose hypothyroidism, THS,
TSH.
is one of the worst and
Well,
most useless tests that doctors ever do.
Well, the problem is that that's not a good enough test for. It's a fine test for primary hypothyroidism, but there are subtle thyroid alterations that sometimes are not picked up with TSH alone. We in pediatrics never draw TSH alone because central hypothyroidism is as common as primary hypothyroidism. So we always get a free T4 and a TSH. Sometimes you even get a T3 in order to answer that question. So we're a little bit more adept at that. The problem is we're not seeing the menopausal patient.
Yeah, well, one of the problems with the TSH test is that they define normal as anything that's not 2.5% at each end.
Yeah.
Which means that
Right.
that by definition only 2.5% could be hypothyroid,
I hear
which
you.
is ridiculous. But
listen,
anyway, I give the mic up
Not
here.
wasted on me. I get it.
Yeah, you get it.
Okay.
Okay, how about one last question, just in the interest of time?
Sure.
So a couple of questions here. One is, how about diet
Yeah.
drinks?
Everybody wants to know about diet drinks, or diet sweeteners. Okay, everybody wants to know. And there's a simple answer. I don't know.
Oh,
It's not that I don't know, I just don't know. I know everything there is to know about diet sweeteners, and that's why I know we don't know. There's something called pharmacokinetics, and there's something called pharmacodynamics. They are not the same. Pharmacokinetics is what your body does to a drug. Pharmacodynamics is what a drug does to your body. They are not the same. We have all the pharmacokinetics for all the diet sweeteners because the FDA demands it. We have none of the pharmacodynamics for any of the diet sweeteners because the FDA does not demand it. Since the FDA does not demand it, the food industry doesn't do it because those are expensive studies and they can't help their sales, so why bother doing it? The NIH won't pay for it because they say that's the food industry's job. So the FDA doesn't demand it, the food industry won't do it, and the NIH won't pay for it. We have no data. That's the problem.
and
That went a little fast. Which do we have the data on? What it does?
Pharmacokinetics. So what your body does to it, because that tells you about acute toxicity. So the FDA's job is to prevent things from hitting the market that are acutely toxic, that are acutely poisonous, that will put you under, after one dose. Okay? Like, cyanide. That's acutely toxic. So you can't put anything out on the market like that. But they don't care about chronic toxicity, and their own rules in the Food, Drug, and Cosmetic Act of 1938 actually say that they don't care. In fact, that's one of the ways tobacco got around it, because is tobacco toxic? Not acutely. Chronically, you betcha. But acutely? Did one cigarette ever kill anybody? So the FDA had no authority because the FDCA of 1938 didn't give it to them. All right? So the FDA has its hands tied in terms of looking at chronic toxicity. And pharmacodynamics would tell you about chronic toxicity, but they are not interested. They don't do it. And the food industry doesn't want to open up a can of worms because it can't help them. So why would they do it? So there's all this stuff out there. And then there's this other thing, which really gets me going. And I'm writing a Huffington Post op-ed on this right now, on something called GRAS. Anybody familiar with GRAS, G-R-A-S? Generally regarded as safe. Do you know that there are 1,100 items on the GRAS list, and the FDA doesn't know what most of them are? And the food industry doesn't have to tell the FDA that they've decided that a compound that they're putting into food is GRAS. They don't even have to tell them. So the FDA doesn't even know what's out there that's GRAS. So I'm writing a HuffPost article called "GRAS, Smoke It, Don't Eat It."
Could you comment on your own personal health? Do you eat sugar?
No.
How about your weight?
My weight's high. My
Okay.
weight's been high for a long time.
Okay.
I exercise. Okay, when I exercise and I exercise consistently, my waist circumference goes down and my weight doesn't change. But my waist circumference goes down, so I know I'm getting better, and I know I'm feeling better, and that's good, and that's what I do. I stay away from refined carbohydrate and sugar mostly. I've admitted to Alec Baldwin on his podcast that in the morning I have a half a bagel with cheese or whitefish salad, and that's my own failing. But I rarely eat dessert, rarely, and there's no soft drinks or fruit juices in the house or anything like that. So I try. I'm not perfect. I struggle like everybody, but I know that exercise solves most of these chronic metabolic issues. Weight being high or not.
Do you do diet sodas or diet drinks?
No.
Just water?
Water, a lot of black coffee. And if you take my coffee away from me, I will kill you.
Cappuccino?
Just in the interest of time, we've extended beyond the question and answers. If you want to, we're going to actually separate for book signing. So if you have questions, he has given you your email to follow up. Definitely appreciate your time sticking around. And we want to thank you all for attending tonight, as well as Dr. Lustig.
Oh, my pleasure.
we wanted to give you a healthy dose of fruit.
Oh.
Real food.
Thank
So
you. Oh, great.
Thanks for coming.
Thank you. Thank you.
And,